All right, hello everyone. Hello. You can hear me all right? All right, folks from the back, folks in the kitchen, do you want to come in? Come in, come in, come in, don't be shy. There's still loads of seats here. It's great to have you all here. Thank you all for coming. The first meetup of the year. Happy New Year, everyone. Happy New Year. Give yourselves a hand. So it's great to be back. It's great to be back. And I want to thank Mainmatter and Shuttle for working with us for this very special event. I'm just going to give a quick hello and then we'll hand over to the Mainmatter and Shuttle team to continue this evening. I'm just going to give a very quick customary opening address. For the people who are here for the first time, this is the Rust London user group. All good, thank you. This is the community for Rust developers, for Rust enthusiasts in the City of London who want to learn together and grow together as a community. We're one of the first communities that came out of Mozilla, and we've been growing ever since with the language and as the ecosystem has grown. So if you want to come and hang out with folks who are learning the language, who are growing in the language, growing in the ecosystem, this is a great place to be. We always have events for different levels of people, and it's great to kind of be around your peers and learn from your peers at the same time as well. So we have 3 different types of event. We have a code dojo. Ethan, do you want to give us a wave? There he is, right at the back. That is directed learning, where you will come in and it will be like a lecture and you'll go from 0 to hello world in Rust and beyond. We have a hack and learn. We're going to be doing a special hack and learn this year. I'll talk a little bit more about that. That's more of just a hangout. So there's no real agenda there. You'll cluster yourselves up in groups and you'll learn from each other and peers. If you want to do a leak code exercise together, if you want to just talk shop in a group, that's what the hack and learn is about. And then you have the London Talks, which is this essentially, a conventional meetup format where somebody can stand up here and share a concept, share a project they're working on, or a company can share what they're building in the language. Again, I'm going to stop saying this because this is grossly outdated. This is showing companies that were using Rust in production. We've gone way past this now. There are so many different companies using Rust in production, not just here in London, but globally. It's a great time to be in the ecosystem. It's a great time to be learning the language. And it's a great time to be like looking for jobs in Rust as well. Even though there is the thing to moan about that there aren't any junior roles. I know. Everybody wants a senior Rust developer out the box. But it is still a good time to be learning and growing in the language. And there are companies that are willing to nurture you, willing to take a chance on Rust developers as they're taking a chance on Rust themselves. We have a community recruitment partner. So again, don't come and talk to me about like jobs. We have a specific community partner who can help you with your CV, who can help you understand the landscape, and who can point you in a direction of companies that are hiring. If you represent a company here that is hiring, you want to talk to these folks because they'll be able to help you find the Rust developers in London that you can grow with. Simple code of conduct, just simple, decent human being stuff. Just please be nice to each other. We always want to foster robust debate and conversation and everything else, but just don't be silly about it, all right? And please follow us on Rust London. I still call it Twitter. I don't care what anyone says. And we also have a YouTube channel, Rust London, where you can find some of our archive talks as well. And here we are, Rust London. Rust Nation, I should say, sorry. Who's coming to Rust Nation? Give me a wave. Great, great, loads of hands. Want to see more hands? This is the UK's first, and it is the UK's only Rust conference. It's actually the largest gathering of Rustaceans globally. We are going to have an incredible time. It's going to be 2 days of conference. There's also an optional workshop day as well that you can buy as well. We have Mainmatter, who's going to be taking one of the workshop tracks. So Luca, give Luca a shout here. Give him a hand. Luca's going to be teaching the expert track on testing, right? So check out the website, check out the details. We have a promo code for the conference days only. So if you want a promo code to make things a bit cheaper, convince your boss, get him in a headlock, get them in a headlock to buy you a ticket, we can help with that in any way. We also have a personal affordability scheme where you can apply for that. We also have student tickets as well. So hope to see you all at Rust Nation in March. It's going to be a great time, and we're really looking forward to seeing you all there. Check out some of the talks as well. Right, I'm very happy to hand over to Mainmatter, Luca from Mainmatter, so please give him a hand.
Lovely, can you all hear me? Yes, that sounds good. So, we are one of the co-organizers of these events, together with Shuttle. It's going to go right after me. This is the commercial breakdown. You need to suffer this at the beginning of the event. Who is Mainmatter? Mainmatter is a consulting company based in Germany. We work with teams all across Europe, and as the slogan says, we try to partner with companies to make them successful. In particular, when we work on the back end, our focus is on Rust, and specifically on Rust on the back end. We do APIs, data workers, data pipelines. We just published today a case study where we built a several petabytes data pipeline for machine learning training. This is the thing we do. And we do this in three main ways. We partner with you in terms of training, so trying to upskill your team so that they can actually be successful using Rust in these kind of use cases. We do it with team augmentation, so embedding some of our people inside of your engineering teams to make sure that they can deliver while they get upskilled on Rust and the architecture required. And last but not least, we do code audits, which is basically bringing a person who's an expert, have it have a look at what you've done, and get some recommendation how to move forward. You'll be hearing a lot more about this later on, where I'm going to be speaking about adopting Rust and what that looks like, so I'm not going to bother you too much. And I'll leave the floor instead to Nodar, who's the CEO of Shuttle. Show of hands, please.
Hope this works. Hello, everyone. Really amazing to see such a great group of people gather here tonight. As Luca said, I'm Nodar, co-founder and CEO at Shuttle. I have some of my team here tonight as well, and I think the rest are watching. So big show of hands for them, please. So maybe the good thing to start this with is why we actually decided to do this event. And one of the big reasons was actually, well, it got inspired by Eurorust, I think, and our experience there. And big shout out to Mainmatter for organizing such an amazing event. We, as one of the sponsors, had a booth there, and we had many people come to us and talk about their experience using Rust. And what we've realized is there's predominantly two main types of Rust backend developers. Ones who are happily using it at work in production and are full of success stories and want to share them. And the second type, which is those who are still sort of considering or maybe trying to convince their coworkers, their seniors. I mean, it's probably familiar to a lot of you. And so what we realized is our role here is actually just bridging that gap, right? Is how do we get people who have those success stories to talk to people who need to hear them? And so this is what we're doing here. And thanks to all of you for joining. I think another kind of reason for this is to continue building a community in London. I think it's really great to have like-minded people, to have engineering talent, people who are coming together to discuss the latest and the greatest, in this case Rust, and discuss the latest developments, what's happening in the world. Clearly, a lot of things are changing right now, and changing really fast. And to stay on top of this, it's great to have people to talk to about all of this. So thanks a lot for coming. maybe now actually to talk a little bit about Shuttle for for those of you who don't know. So ship Rust apps fast. This is kind of like a slogan, still work in progress. If you have any other ideas, would love to hear. But basically what Shuttle is a backend development platform. And what we're doing is redefining backend development using Rust. And the framework that we came up with is called infrastructure from code. And the idea there is that you can build and ship backend services really fast without writing any infrastructure files. So you just add annotations to your code, and this is pretty much how you create backends. And the bottom line here is that it's the simplest, easiest, and fastest, most enjoyable way to deploy your Rust code right now. So check it out. And the reason why we created Shuttle, why we created it, is pretty much this. and what we've realized, like many of you may have realized, is that the backend development experience is still to a large extent not great. Many companies have tried to address this problem, but it's still an open problem. And so this is why Shuttle is there. We want to see something as nice and smooth as some of the amazing products that are out there on the front end, creating like really smooth experience of development. And that's what we're creating for the backend developers. So hopefully some of you can check it out as well. And maybe last bit here, we are actually hiring, so that's that's a plug, and that's very convenient that here we have a lot of talented engineers. So if you're interested, check this out. We'd love to speak to you. There are more people from the team. Myself, I'm wearing a t-shirt. The rest of the team did not think to wear their t-shirts, but you'll probably find them out, and they'll introduce themselves as members of the Shuttle team. Cool, check it out, Shuttle.rs about. I'm not going to click the link here because I don't know what's going to happen. Cool, thanks everyone.
Okay, so logistics. What are we doing tonight? There's going to be 3 main talks. We're going to start with Edward from Vortexa. He's going to explain what Vortexa does, and most importantly, what Vortexa does with Rust. Then it's going to be myself, who's going to be talking about Rust adoption. We're going to have a little break there, like 10-15 minutes, and then we're going to have a panel with the 2 speakers, Nodar, as well as a 3rd person from Arwed Node AI to discuss Rust in production. What it looks like, what are the issues, and that's going to be a space for you to ask questions if you have any. So go wild at that point. At the end of the panel, there's going to be food coming in, so wait for that. Said that, stage is up for Edward. Give him a nice show of hands, and let's get started.
Hope you can all hear me okay. Be a short moment while we change the technology. Right. Well, it's great to see you all here. Thank you for coming. My name's Ed Wright, or Edward Wright. I work for Vortexa. Just a little bit about me, and then we'll talk about what Vortexa does and get into the meat of it all. So I've been doing software longer than I can remember, so it's going a bit grey here. I started probably at college learning C++, because back then they hadn't invented Java yet, which I was quite happy about because I got into some quite low-level coding and understand how the machine works and memory mapping and all these good things, bit twiddling, which my colleagues will recognize in me. Java came along, and I had a long, glorious history of doing various projects in different investment banks, moving data around, some of it low latency, some of it not. Some of it was quite interesting, but then I got into energy, worked for an energy company, and then joined Vortexa as a startup, seeing this company grow from a tiny little baby of 2 people to the company that it is today, about 125. So yeah, C++ initially, then Java, and now Rust. Let's see where this is going. So what is Vortexa? Vortexa, I would say, is not a software company. Software is a means for the end. So we are using it as a tool. It is not really what we sell. What we sell is information. We are working in the energy market, and we're actually taking information from hundreds of different data sources, some of it at quite high frequency, aggregating this over time, slicing it in probably just on this screen about 30 different ways. We have lots of advanced filters that you can use. And it's used in the energy market for trading. So people actually look to see, for very specific products in different areas of the world, what are the imports, what are the exports, what are the trends, what's happened over the last year, 2 years, something happened in the news, how is that impacting things, are vessels being diverted, which is infecting the future flows and the imports and exports that are happening in the future. So we take in the data, we aggregate it, we slice and dice it, and we produce information for our clients. So this is just one of the many screens on our platform showing flows of different products. This is another screen, just an example of what we're doing. It's showing, we call it the map screen originally. It's showing this, in total we're probably tracking over 14,000 vessels around the planet. On each one of these you can click on them, you can see what they're carrying, what product they're carrying. There's hundreds of different products which we need to infer. Some of this is coming from hard data, some of this is coming from machine learning models, and people can see what's going on and dig into the information however they wish. The funny colours you can see there was just a weather overlay, so people can actually see the impact of weather as well on our map. There are different overlays for different kinds of information. So, we have, historically, to date, about 380 billion data points. We're receiving about 5,000 new data points every second. So it's pretty high frequency. We have hard data from many different data sources, such as port agents, people around the world giving us hard information on how much a vessel is carrying, what product it's carrying. That data is incomplete. So we are trying to produce a complete picture from incomplete data. So a lot of it needs to be inferred with machine learning models. I'm not going to lie and say Rust is some beautiful, Vortexa is some beautiful Rust utopia and we do everything in Rust and we're just a Rust shop. It's not true. We use lots of different technologies, but Rust is part of that equation. I would say we've got about 120, 130, no, 125 counting employees, approaching 130. We've just passed Series C investment, which is giving us a big injection, investing into our future and developing new aspects of our product. We have a roadmap. It's not something I can talk about, but exciting things coming up. There's always engineering to be done, lots of engineering. I'd say we do streaming, data processing, where our latency is measured in seconds. So we're getting data from vessels, and within seconds this information is on our screens. And there's also what we call batch processing, which is using a batch framework called Airflow, where we have lots of tasks doing lots of processing, because as anyone who's doing machine learning here will probably know, is doing inference in a streaming manner. It's feasible, but it's not simple, and it doesn't play well with how data scientists often operate. We provide an API as well as a UI to our users, so people can access us through a web browser, but they can also access our data programmatically, so we get tightly integrated into our customers. And yes, we're used by energy customers, finance customers, and government. So how do we start with Rust? And the answer is by accident. It wasn't planned. I can't actually say, I know there was a discussion earlier about talking to management in your company if you're at that stage and saying, is this a technology choice that we should choose? I don't think that conversation even happened. I think we just had a developer who said, I'm going to do this. And it happened by accident because he was writing a piece of software to actually work out the path of vessels traveling around the world. He wrote it in Scala. He was a data scientist, this gentleman. He wrote it in Scala. I'm not going to mention names, so I can say it was done badly. It was done badly. The code was horribly slow. So he thought, because he was interested in new different technologies, he'd give Rust a try, because it does have a reputation for many things, but one of them is performance. So he ported that to Rust, and I would say he didn't do it in a... when I'm thinking Python, we say Pythonic. What do we say? We don't say Rustonic, do we? Rustic. Yeah, it wasn't very rustic at all. Unless you call it rustic like countrified. But anyway, it wasn't really respecting the rules of Rust. It was trying to do data structures like you would do in another language, which is probably a lot of, quite a common problem that developers coming from other languages will face. They try to use the new tool in the same way they use the old tool, and it's not always the right way to go about it. So there was a lot of unsafe code, there was a lot of pointers going all over the place, and despite all this, it was still terribly slow. He then left, not for that reason, but this project has then been since developed. I took it on board and we got it down from using, I haven't really explained what it does yet, but we've got it down from using, it was using about 240 gigs of memory and 70 cores, and now it's using less than 2 gigs of memory, and you can run it on, I actually have run it on a Raspberry Pi for fun. So we've downscaled it somewhat. This project is called Pathfinder, and as the name suggests, it's actually working out the path vessels take when traveling across the oceans. So I have an example again from our platform. This screen is called Voyage Calculator, and it's a simple UI with a map, and it's actually calling this Pathfinder service behind the scenes. And essentially, you have a model. It's a graph of over 1 million points with about 40 million connections, linking basically all the oceans and rivers of the world. And you just give it a starting point and an ending point, and it will find you the best route between them. There are subtleties such as avoiding coastlines. There's subtleties that certain sizes of vessel can't go in certain places. You would not expect a giant vessel to go up a river, for example. So there are some constraints in this model, but that's essentially what it's doing. This is just an example of the model zoomed in, actually, just a very small area around Rotterdam in the Netherlands, just to see the actual complexity of the model. So you see all these interconnected nodes. Each node is, on average, connected to 40 other nodes. Now, that's the average. There are some nodes which have hundreds of connections. So it's a quite complex model. But because of this will actually give you more accurate routes, and the routes will look sort of curved and follow great circles and actually correspond to reality a bit better. So let's start with the wrong solution, the one that was done in Scala, and essentially the one that was done in Rust as well. So we have a request coming in. We have this model with over 1 million coordinates in it, with all these interconnections. What we don't have is a model that contains your starting point and your ending point, because the chances of those coordinates, some of them might be coming from a vessel, so there'll be GPS coordinates, a signal that you received. The chance of those coordinates actually being in your model, it's not nil, but it's nearly nil. But you need a model that does include those points, because you're trying to create a path that includes the entire path from where the vessel actually is, not near where the vessel is, but actually where the vessel is. So what was done, and I'm sure everyone who starts getting into Rust, one of the first hammers, one of the first tools you grab hold of is clone. just clone things. They clone the model so they could then modify the model. That was expensive. That was like 6 seconds expensive. Now, if you're doing a web service, and if you've got a web service which is backing an interactive use within a UI, for example, I'm sure all the web developers in the room, when I say 6 seconds latency, they're going to scream in horror. This is just not good. This is not good at all. It did work, but this wasn't the way to do it. So once the model was cloned, we could run our A-star algorithm. The algorithm is actually called A-star, and we get results. That's the wrong way to do it. What's the right way to do it? And the interesting thing about this is it's not really a story about Rust. We're using Rust technology, but this is just software engineering, and I'm going to come to that point soon. So now we got a request coming in, and we actually have an immutable model. And because it's immutable, we can happily share it within threads, so our service suddenly becomes much more scalable. And we create a really thin layer on top of the overrides, which is this is the part of the model that's being modified by your request. So you may have 1 million nodes with all those interconnections in the immutable model, and you may have 24 nodes in the override. So that can be created in, well, it's hard to measure. It's not even a millisecond. It's incredibly fast. And this is using, of course, a lot less memory as well, because before we had lots of requests coming in and different threads. It was all running in parallel. Each one had its own entire model. So that's how the old service was getting north of 200 gigs of memory used. And now we don't have to do that. And we got something much more scalable. This thing is running under 2 gigs. and we get results. So, the point being, why Rust? Why did we get into Rust? It's no substitute for good software design. I think that's the message I'm saying. There isn't a silver bullet where we use some language, Java, Python, pick a language, and that's bad. We'll move to Rust, and it's good. You can make a mess in any language. So I just want to put the point out there that software engineering, there's no substitute for that. And each language does have its own best practices. So you must take those into account. Rust has been incredibly reliable. Some of that I will put down to all the rigorous checks that are put into the compiler. I suppose the mantra I work with is, if it compiles, there's a good chance it's going to work. Those of you who've used Rust are probably quite aware of how that feels. We find that when we build things in Rust, they are pretty easy to maintain. They just don't break. They don't break. Our requirements can change. We may need to modify them, but it's pretty reliable as well. And because we're not bogged down with trying to find stupid threading bugs, because we've got immutable data, because we've got a language which just allows you to do whatever you want and completely make a mess of things, we're probably spending our time more focused on actually adding value for our customers and changing things when the requirements change. Work that we should be doing rather than busy work. And it's opened up new possibilities for us as well, things that we couldn't do before. What kind of possibilities? So one research project I'm working on at the moment is we have a machine learning model which is predicting where vessels are going in the future. That's actually quite key to what we're doing, because if you think you want to know, for example, if you put your trader hat on, what's the exports of, I should say imports really, what's the imports of gasoline into France in 2 months' time? What might that be? You need to look at where all the movements of energy moving around the planet are going, predict which vessels are going to go to France in the time frame that you want. Are they carrying the right products as well? It's absolutely key to be able to predict where these things are going. I don't mean the path, I actually mean the destination. And one thing I'm working on is a model where if we could look at a ship anywhere in the oceans or on a river, anywhere in the world, and see which direction that vessel is sailing, this is just one aspect of the model, just one feature. We can actually see, is it sailing towards a port, or is it moving away from a port? We have thousands of ports. So imagine you've got a vessel which is off the coast of Chile and it's heading south. Is this vessel heading towards Rotterdam? It's very far, but is it? It could be, because there is a route going around South America and then crossing the Atlantic. It could be going to Rotterdam. If it was in Chile and heading west, it's probably not going to Rotterdam. So the direction actually matters, and it matters at distance as well. So I'm trying to create a model which has a huge combinational variety. You've got all these different positions around the world. You've got thousands of ports. You've also got many, many different sizes of vessel as well. And some can go in certain places, like I say, because there's restrictions with rivers and canals, and some can't. So you're not going to get the same route for different vessels. So basically, from any point on the planet, I'm trying to work out for every port on the planet, and for every kind of vessel, which direction should you go? That's a lot of combinational factors. Initially, we're starting by looking at these points from the previous model. So we've got about 1 million starting points on the planet, and using this A-star algorithm. This is not a good algorithm for bulk searching. And this was actually taking about 8 hours of processing for a single port. We have thousands of ports. It was going to take months of processing, unless you scaled it really wide on the cloud. So either a lot of time or a lot of money, one of the two. And you'll get results, and you might have a bug in your code. It might not be good. You might have to do it again. This is a terrible developer iteration experience. Change the algorithm. This is coming back down to software engineering, using the right tools. And you can get results drastically faster. Now, for one port, using all the different combinations of vessels, we can calculate it for the entire planet, not in 8 hours, but in 90 seconds. And this is part of the Rust story, because Rust allows us to use threads efficiently and saturate a machine really, really easily without a lot of the pitfalls that other languages might have. There's languages which just plain can't do that without multiprocessing, such as Python. There are languages like Java which allow you to do that, but then with multi-threading you can really make a mess with your data structures if you're not careful. You can do it well, but you just need to be so careful. So this is when people say multi-threading is hard. But for many classes of computation, you can just borrow the crate rayon and then of your input data, iterate in parallel over it, which is what I'm alluding to there on that last line of code, where you just have a collection of points, of centroids, and we can just iterate over those in parallel. That one line of code, calling an algorithm, will happily saturate a machine, and it doesn't matter if it's got 2 cores or 100 cores. So you can really plow through a lot of processing quite simply. These are the results. So this is just showing calculations for one port in Indonesia. The headings are actually encoded into the colors. So if you imagine where Indonesia is, you can see in South America there's a discontinuity because you're at the other side of the planet, and is the best direction east or west? There comes a point where you would actually go the opposite way. The discontinuity that's south of Indonesia, that's more just the way the colors are rendered, because if you're going a little bit east or a little bit west, it's going to render it as a different color just because of the circular coordinates. But that whole map, which is over 1 million data points for a certain vessel class, was calculated in 450 milliseconds using a single thread. So Rust is really, really powerful for getting results quickly, iterating, and actually producing a model which can improve our accuracy and improve our data quality. And like I was saying at the beginning, Vortexa is a data company. We are actually judged on the quality of our data. So let's talk about some integration with the languages. So, correlating vessels at sea. Sometimes vessels get quite intimate. They get quite close because they want to actually transfer cargoes at sea. You may have a port which isn't very deep, the water isn't very deep, and a huge tanker cannot come into port. So you'll actually transfer some cargo at sea and then use a smaller vessel to actually bring it into port. And we need to detect those. We have billions and billions of input signals, and we have certain areas of the world which are interesting for doing this. So we have what we call polygons, shapes, if you will. We're using pointing polygon math to work out which of all these signals going around the world are actually interesting for this algorithm. If we apply this algorithm across the planet, it's going to cost too much in computation. And also there's plenty of areas of the planet where this doesn't happen, and we'll get false positives, we'll get lots of noise. So we need to filter it down. We're talking about a filter here. The focus isn't so much on the actual model. Now, before I get into this code, let me just stay on the last slide actually. The problem is we were doing this filtering processing in Python. We tried different libraries and everything, and when we're actually training our model, we're actually going through all our historical data, billions of data points, and the processing was taking about 30 hours, which is a bit horrible for developer iteration, and quite expensive to run. And it seemed that like about 26 of those hours was in one method. Well, that's interesting. So let's optimize that one method. Now, we're using a crate called Pyo3, which allows Rust to integrate pretty cleanly with Python code. We are a data science shop. We have lots of data scientists. They like using a tool called Pandas. I do apologize. It's a little bit like productionizing Excel. Imagine an Excel spreadsheet in source code. You're not far off. But we do have Pandas code. Sorry. And one thing you can do with Pandas is you can extract columns of your data using another Python library called NumPy. Pyo3 allows Rust to grab this data from NumPy with zero copy. Very efficient. But we're not going to use zero copy. We're going to copy data. I'm a bad software engineer. No, really, there's a good reason to do this. So you can see on this method here, we're passing in the data with NumPy arrays. Now, Python has a thing called the global interpreter lock. I'm not going to teach you Python this evening, but basically, the data structures in Python can only be accessed by a single thread at any one time. They are not send, they are not sync, you can't pass them between threads. So that's a bit of a pain, and we want to really leverage Rust to the maximum. So what we actually do is we copy that data into a Rust data structure in a single thread, which isn't perfectly efficient, but let's continue. Then, having made that copy, we can then use Rayon to actually do the pointing polygon math en masse across all those coordinates very, very fast. And then we can gather our results, unfortunately, in a single thread again, and send those results back to Python. So we have a mini map reduce thing going on here. Despite the fact that we've got those single-threaded sections, this is vastly, vastly quicker. So we added about 400 lines of Rust code to this project. It's pretty small. That's including a custom implementation of pointing polygon. We're using some cheats to actually make it more efficient. We're avoiding floating point, for example. It's about 400 lines of code, and the 24 hours of processing that one method, that filtering method, was taking now takes 1. So the whole process is taking 6 hours instead of 30 hours, which is a massive difference. It's no longer a hotspot. But more importantly, because we work a lot with data scientists, the actual model code, the bulk of the code of this project, remains intact. We didn't have to modify it. We made a surgical alteration. So I think this is one of the messages I want to deliver today is you can use Rust surgically to make a big difference. It doesn't have to be a rewrite everything. I'm sure there's lots of Java fans in the room. Do bear with me. So the next thing here will be again working on our destination model, predicting where vessels are going. Again, this is a machine learning model, so we need to train it. So as well as doing inference on streaming data with reasonably low latency, we need to do bulk work to do the training. And this was even heavier than the last one. So we have signals coming in, we have some business logic that processes them, and that needs to call this Pathfinder service because it needs to work out how far away the predicted destination is. It's actually working for an estimated time of arrival. We want to know when the vessels arrive, not just where. That was packaged up as a web service going via an AWS load balancer. And so this is a simplified diagram, but you can see that the business logic is calling out to this backend web service, doing its thing and producing results. During training, this was taking multiple machines working in parallel about a week. And it was costing, one inference run, one training run was costing about $1,100 in Amazon costs. Also, you have developers and data scientists twiddling their thumbs, going, when is this thing going to finish? Is it going to finish? Is one of these machines going to crash? Or did we even write the software correctly? And when we got the results, are they right? It's a terrible iteration experience. So what we did was the same story to before. Let's integrate some Rust code in the hotspot. And this time, we're taking that entire shortest path algorithm that we talked about at the beginning of the talk and packaging it up as a Java library. So this is just a tiny bit of Java that I'm showing you here. And the interesting thing is probably the first line of code, which is just that's like an I64 in Java speak. It's a 64-bit number. And we're actually storing a raw pointer in Java, which is a bit radical. But basically, Rust is going to do its initialization code, which we'll see in a second, create all its data structures and everything, and then we're going to create a boxed pointer to that, store that in Java as a number, and then every time we want to call Rust, we take that number, we pass it into Rust. Rust can actually cast that back into its data structures and use it. So this is how Rust keeps its context. So here you can see the initialize stuff. I'm not going to show you all the initialization code, it's not very interesting, but the last line of code in there, you can see we're actually boxing, using Arc to be multi-threading friendly, a point to our data structures, and we're using a crate called JNI And JLong is just an alias to I64, like I was saying. Then the actual processing code. Now, please don't look at this slide too carefully because you'll go blind. But basically, the interesting line of code is the first one in the function, the let state line. This is the only unsafe code in the whole library, and that's just basically casting back this raw pointer, this just 64-bit number, into our data structure, so then we can do some work. The rest of it is Java reflection, lots of Java reflection. Every single class, every single type, we have to look up dynamically, and that code is quite painful to write, to be honest. But basically, going back to this is our new model now. We're using it in process, so it's now a library. It's just a function call. What are we avoiding? We are avoiding a network transit. We are avoiding a load balancer. We are avoiding auto-scaling issues. When this thing starts, it immediately puts on massive compute load. When we were using the web services, they needed to be scaled up. When they were scaling up, each one of those needs to load a model. That takes some time. Because that takes some time, some web requests fail. Because those web requests fail, our code retries. That amplifies the load still further, causing more auto-scaling. So the back pressure wasn't working well at all. And we have the serialization issues too. So we're having to serialize because we're using a network stream. Now we can actually just pass data structures directly between the two languages. And yeah, when we did this, our inference went from 1 week to, I think, under 24 hours, using less resources, and it costs $80 now instead of $1,100. So now we can iterate much, much faster. So in summary, language integration is a thing. I think many companies are beginning to do their journey into Rust, would I say. It's probably not the starting point that they're in. Maybe if you're looking at a greenfield startup, you could start it Rust from scratch. But there probably is prior art, there's probably existing code. Could be Python, could be Java, could be something else. There's lots of integration to be done. And just use Rust as a tool to make a difference where it really can make a difference. And that will allow you to develop your models, develop your features, bring things to market quicker, serve your customers, and make profit, which is what we're doing. Thank you.
Hello, let's open the floor to 2 questions because we're a little short on time. So let's start with one. Ooh, right there. Trying not to die.
Thank you. Thank you for the interesting talk. You mentioned that you guys use pandas and you have some specific way of interacting with Rust on that. Have you considered pollers? Because the backend is written in Rust and interfaces with Python. And if you tried it, did you find any difficulties integrating your business logic?
It's a good question. I think we have done a bit of research into polars. We have a moving target. We have a large code base and a lot of projects, and this research just needs to be balanced with the continuing torrent of demand, I would say, from the product side of things for new features. But it certainly could be a valid approach. Absolutely.
Hi, thanks for the talk. I might have missed something, but I did not quite understand why using Dijestra's algorithm was faster than A-star.
Okay, so A-star will actually give you the route from one starting point to one finishing point. So I want to know from a certain place on the Earth what is the best route to a few thousand ports. So I would need to call A-star a few thousand times. Which is going to revisit the same parts of the map many, many times and do quite a lot of calculations. Then I multiply that in turn by the number of vessel types I've got as well, because we're interacting with rivers and places where certain vessels can't go. If I go to Dijkstra, Dijkstra will actually scan the entire world, and basically I can go through the entire graph and just make a note of every time I come across one of my ports. So I just do one big calculation. I'm not saying it's a million times faster. It's not. You still do have to visit every single node in your world to do this, but it is much, much faster. I was actually shocked at the difference.
And that was all for the Q&A now. There's going to be a panel later, so if you have some questions, write them down. But other than that, big show of hands for Edward. And now we switch computers.
Okay. Nice. I'll self-introduce myself, as it happens, but this is the second talk of the evening, and we'll be talking about adopting Rust. Now, when you try to have this conversation, usually it's from the point of view of a Rust advocate. You know, it's about how do you persuade your manager to use Rust. That's often the undertone, which I think is an interesting skill to have. That's something I've done in the past, actually here at TrueLayer. Which I realized we haven't tanked. TrueLayer is hosting us tonight. They're also a company that uses Rust quite extensively. So if you're interested into Rust, that's a good place to find. But it was a company that was not using Rust at the beginning. I did the process of adopting Rust here at TrueLayer years ago. But there's a lot of content about persuading managers, and I think there's not enough content about, you know, you're persuaded, like you're convinced that you want to do Rust. How do you do this thing? Like, how do you roll out Rust successfully? How do you get your first project, you know, up and running without doing a badly written Rust rewrite, as we saw in the previous talk? As it happens, you can write bad software in any language, including Rust. It needs to be said. So this is what this talk is about. Like, you are convinced you want to do Rust. How do you make that process a success? And before we get into the nitty-gritty, I'll give you 2-3 informations about myself. Name is Luca Palmieri. I work for Mainmatter as a principal engineering consultant, which basically means I go around and do talks like this and partner with teams around the world. You can find my Twitter handle. I'm also nostalgic, like Ernest, right there. And there's also the link to my blog where you find my stuff. I have done a bunch of stuff in the Rust community, libraries, tools, trainings, but I'm probably best known for being the author of this, Zero to Production in Rust, a book teaching you how to use Rust for backend development. If that's something you're interested into, pick it up, it's nice. Other than that, I'm currently working on PaveX, which is a web framework, not yet released in private beta, which hopefully is going to be very nice to use. If you're interested, there's a link there as well. Said that, let's get to the meat of the talk because the night is short. 2 main things, how to build your first Rust team, and under the assumption that was successful, how to scale that up to 2, 3, 4, 5, 6 teams, whatever that is. So building your first Rust team, first choice, you know, first impulse that you might have is, okay, I'm going to hire a bunch of Rust people. And as Ernest said at the beginning, obviously I'm going to hire a bunch of senior Rust developers, which happen to be, you know, everywhere. You just need to go and grab them. The reality is just don't do this. And the reason don't do this is twofold. Number one, there's not that many senior Rust devs. Like, if you go out there looking for Rust production experience, so folks who have been there and have built non-trivial Rust systems which have been running happily, hopefully, for a few years, there's actually a fairly small pool of people. Rust has been around for a long time, but has not been that popular for such a long time, which means that a lot of companies are actually picking up Rust now. The people who have years of production experience are few, and they command very high salaries. So hiring would be slow and expensive because you're all competing for the same folks. And depending on how deep your pocket is, you might or might not be able to afford it. Second thing is, if you're just starting with Rust, right? Like, you're a company that's evaluating their first Rust project, how committed do you truly are to Rust? If you go out there and you say, I'm hiring for Rust jobs, you are gonna get a lot of people who wanna work with Rust. Now, what may happen, and in any experiment needs to be a possibility that you are contemplating,
is that the experiment doesn't pan out. You know, this Rust first project, this Rust adoption thing, just, it's not right. Either it doesn't succeed or you realize that it's just not the right thing to do. Now, if you bring on board a bunch of people for Rust jobs, and then suddenly you have no Rust projects, I don't need to explain to you how that is going to end. So it's going to be unpleasant for both parties involved. So don't go out there advertising Rust jobs until you truly think that that technology is going to pan out. Otherwise, things might get rocky. So my suggestion, generally speaking, is if you want to use Rust and you want to do a Rust pilot, start by looking internally. Like, what folks do you have on your team? Now, first and foremost, let's cover the basics. Do you have anyone who knows Rust? Which you might say, you know, I should know that. Not necessarily. Like, these people might be using Rust in their spare time. They might be doing, you know, a home lab, a little Arduino project. They might have got some handiwork with Rust that they haven't necessarily shared with you. Or you might be very lucky and, you know, you got someone who was working with Rust in a previous job. That usually doesn't happen, but, you know, there's no harm in asking. If you have one of these people, you want to lean on them. Like, they need to become the fulcrum, the center of your first Rust project. Make it so that they can own and make it so that they can feel that the success of the project is their success. At the same company, you might have 5, 6, 7, 8 people who have some level of Rust experience. You do not want to staff the entire project with Rust experts. And the reason for that is that you want to develop a code base and a code style that's going to be suitable for folks at various levels of expertise to contribute to. If you staff a project, you know, with a tiger team, in quotes, people are very senior, very experienced, you know, are going to use advanced patterns from the get-go. When the project eventually succeeds, you know, what you're hoping for, you're going to have to rebalance seniority. You'll have to bring in juniors and intermediate developers. And if this code base is very impenetrable and difficult to use, that's going to be a painful project. Instead, if you just mix in, you know, a bunch of Rust, more senior people, and a bunch of Rust novices, you'll naturally get a style that is suitable for all levels of expertise. So my suggestion is get some folks, get some champions, but do not stuff the entire team with champions. That can go not as well. Now, you might not be among the lucky few, and so you don't have any Rust experts in your team. So you need to look for language proximity. There's two big families of, you know, languages you can look for. Number one, obvious, everybody's thinking about this, C and C++ developers. They've been thinking about memory, they know, you know, the landscape of what it means to manage memory, and a lot of the patterns that Rust codifies inside of the compiler, they have learned to use in their day-to-day, even if they're not codified by the C or C++ compiler. So these folks obviously will have to change the way they do things, but the bridge they need to cross is not that long. So this is a good pool of people to look from. The second pool, which is not mentioned as often, is actually functional programmers. Because yes, Rust is a system-level language in the sense of it gives you very precise control as to how things execute and how memory is used, but Rust is also a very functional language. Like, you are managing nullability with options, you're managing fallibility with result, you have algebraic data types which actually play a gigantic role in the way you model your domain. All of these things are the bread and butter of folks working with Haskell, OCaml, F#. Yes, they haven't thought about how the bits are laid out on the heap, probably in a decade, but in the same way as C++ folks, they have a shorter bridge to cross. So that's the only thing they need to learn. So if you get folks from one of these two groups, there's a higher chance that they are going to be productive faster than a random person learning Rust. Said that, I learned Rust coming from Python, so you know, everybody can do it. Third thing, and this is often not stressed, but I think it needs to be stressed, you need to make sure that folks want to do this. Like, not everybody likes to do the new shiny thing. Sometimes, you know, there's a little meme that developers always not like to work with the shiniest and newest tools. That's actually not true. Like, if you go around talking to people that actually do the job, a lot of them have a toolkit, they know it well, can get shit done, don't want to be bothered with something else, unless there is a reason to go and learn that something else. So you need to go to the team that needs to develop this project, and you need to be sure that they want to be on that project. Because fundamentally, you're asking them to step outside their comfort zone. And that means being a beginner again, like making mistakes, being exposed. Some people might want to do it, some other people might not want to do it. Check in, like make sure that everybody who's on this project is committed. Cool. Oof. So this stage, you have your team, like you have the people that need to ship this first Rust project. Now you need to make sure that they get in tip-top shape. Like you want to make it so that when they try to deliver this project, they succeed. Because you don't get a lot of shots, bringing new languages into a company. If you miss it, then the next one might never come, or it might be not your shot. So, what options do you have? Number one, self-guided learning, which basically means here's a bunch of manuals. Go read them, come back, and know in Rust. The good thing is, in Rust, there's excellent resources to learn Rust at your own pace. This is how I learned Rust, for example. Just read the fucking manual and then go do it. My recommendation is do a mix of books and hands-on exercises. And that's because you can read books and you can feel like you know the language, right? You read all these books, you never code, just read through, and you get all these patterns and all these names and all this terminology, and all kind of makes sense until you actually go and try to do stuff. And then nothing works, you don't know where to start, and you have errors that you're puzzled at. So you always want to get a mix of reading, so to understand the foundational concepts, so that you can reason from first principles when trying to troubleshoot, but at the same time, you need to get the language going under your fingers. And there's no substitute for that than actual exercise and practice. So if you want to get good at writing Rust, you need to write 1,000 lines of Rust. That's the way it works. In terms of books, to learn the language, my suggestion, pick one of these three, you can't go wrong. Number one is the official Rust book, which you probably know and love, I hope. The second one is Programming Rust from O'Reilly. It's geared towards a slightly more senior developer reading it, which means that it's a bit more faster paced, but that might be something you want, because you know your stuff just from another ecosystem, you just want to translate that back into Rust. Third one, Rust in Action, uses a slightly different approach, is more exercise driven, so you're building small projects throughout the learning experience. And that's actually a very nice way to learn. So any of these three is good, just read one. From there, exercises. Two places to look, first and foremost. Number one is Rustlinks. Rustlinks is a GitHub repository that you can find. I think it's under the Rust organization, if I'm not mistaken. Anyway, search Rustlinks. It's a bunch of exercises, each of which comes with tests. So it explains a concept, like how to iterate over a vector. And then there's a little test to check that your solution makes sense. You do them one by one, and suddenly you start to remember what's in the standard library, remember the key methods, and the language gets fluent under your fingers. The other one is exercise, I don't know, that one, .io. It has a variety of tracks for different languages, one of which is Rust. You can get people to review your exercises, there's a bunch of mentors. It's a very nice way to pick up a new technology. Either of this, just go do it. If you need to go deeper, then the path bifurcates or trifurcates, depending on what you need to learn. If you need to do embedded, there's another free book called the Embedded Rust book. It's maintained by the Embedded Working Group. Very nice point to get started, getting LEDs to blink. If you need to do APIs and backends, obviously I wrote this, I think it's good. You can get zero to production in Rust. If you need to get better at Rust the language, so get more sophisticated, look perhaps at FFI, some of the niche topics, then Rust for Rust Station is a very good read. What I don't suggest is that you read one of the books I mentioned before, and then you go straight to these ones and you never write code in between. That's, I think, a recipe for spending a lot of time without actually learning how to do things. Just warning you. Said that, self-learning can play out beautifully. I've done it. I'm proof you can learn Rust. But it takes a while, because you're on your own, you are reading all this material, you need to metabolize it, you need to make sure you actually understand it. That is a process that takes its time. If you are in a rush, you can opt for a few other ways of getting up to speed or getting your team up to speed, basically. Number one is formal training, which basically means get a person that knows Rust to teach your folks. It's a very common solution to speed things up, and there's two variations of this. If you are a large company, so you have a team of 6, 7, 10, 15, you get a trainer to come at your place. That means that the training curriculum is usually going to be tailored specifically to what you need, so you can make sure you're not wasting time, and it's generally a very nice experience. The alternative, you have a small team, 1, 2, 3, 4 people, you go look for a public training. This might be done by training companies, such as Mainmatter. So once in a while, we say, we are gonna go and do a session on testing, and everybody can sign up individually. More often than not, you can find these at conferences. Rust Nation, Eurorust that we organize in October, there's always a workshop day. And that's a very easy way of going by 1, 2, 3, 4 tickets. At Rust Nation, as Ernest has mentioned, I'll be doing the expert track. So if you're looking for that, please sign up. Said that, the key thing here is interactivity. Like, there's no point in doing a training if you get a trainer, to stand behind a podium like this, talking at you for like 8, 9, 10, 16 hours. That's the same of watching a YouTube video. Like, you can get that on YouTube. What you want is an expert that your engineers can ask questions to, because that's what speeds up the learning process. I'm doing some stuff, I have a doubt. Instead of spending 60 minutes on Google, I ask the person, he explains. Go back, rinse and repeat. If you get this, virtuous cycle going on, then you're actually going faster. So that's the key thing to look out for a training is, am I gonna be able to ask instructors questions? The answer is no, not really a point in doing that. Now, you're even more in a rush, right? So you can't afford to do the learning and then doing the thing. You want to do the learning and the thing combined. This is what team augmentation can do. If you want to do this, instead of getting some experienced people to teach your engineers, you get some experienced people to work with your engineers. And let me be very clear, this is not outsourcing. This is not, going to a bunch of consulting companies. I have these requirements, go build the thing. That doesn't actually make anything for building Rust expertise inside the organization. This is about embedding these people inside of your organization. And the idea is that while your team is learning, they're also delivering the project. Because mentoring and teaching is happening continuously. It's happening with pairing sessions, it's happening on code reviews. Obviously, this is the most expensive option of all the ones I listed, and might or might not be one you might go for. A slightly lighter touch option is code audits, which basically means get somebody who's an expert and come and review my code base. Perhaps you got a bunch of green Rust engineers, they've done something, like Edward was mentioning before, which doesn't quite look right. And then you're like, have a look at this, and then come back with a report. That report will have critical issues, like there might be some very, very wrong things with what you've written. People are like, oh, Rust won't compile if it doesn't work. Trust me, I've seen horrifying things that did compile. Then you're gonna get some recommendations on things that could be done better, might be more idiomatic, and generally, you can waive what comes out of the report in a technical roadmap that you work on at your own pace, whatever that is. And the alternative is to do this at the beginning of the project, so rather than correcting the mistakes, trying to set the project on the right tracks from the very beginning. This depends on what you prefer to do. Now, at this stage, you have done this first Rust project. If it was a failure, you don't get to this phase. If it was a success, then you might get this problem, which is in the category of good problems to have. How do I scale up? So you might get a demand spike, which might be transient or permanent. Like you might need a couple of extra hands for 3 months. If that's the case, don't go hiring full-time employees, get contractors. Sort out the demand. When that's done, send the contractors away and keep going. But more often than not, and more interestingly, the demand is structural. Like you build a product, people are buying it, now you need a larger team to maintain it. And that maintenance goes, for the long term. So how do I go about hiring Rust employees? Well, at the beginning, I discouraged you from doing this, but the reality is that hiring for Rust positions is very easy, as long as you require people to have Rust production experience. And that's because developers are excited to do Rust. Like if you publish a Rust position for a nice company, people are gonna apply in like swarms. I have personally seen this in the past. Like you're gonna receive way more CVs than you can even process. And the key point there is that they're keen to learn Rust. Like there's gonna be some true gems in that hiring pipeline, but everything is conditional on you being able to train them to actually get that gem out of the potential of the person. The good news is, everything you've done so far, so everything you've done to get your first project off the ground and make it successful, everything you've done to get that team in tip-top shape, is exactly the same work you're gonna be doing now for your new hires, with the nice bonus that now you have Rust experts, because you formed them in the first project. So a lot of the things about team augmentation that I was mentioning before, you can do internally with people from the other team, because now you have that central, center of excellence that can train the rest of the company. Now, some practical things that, it's important to mention. I have a Rust job. Who do I tell? Where do I put it? Usual places, LinkedIn, Indeed, whatever is your favorite job board. But there are some few Rust-specific channels which I think you should be keeping in mind if you are a hiring manager. Number one, every 6 weeks there's Reddit, there's a thread in our Rust, which is called Job Seekers and Offerers. I don't remember. Anyway, you can go there, put one comment per job opening. You need to fill some information, so you can't just say, I'm hiring with a competitive package. You gotta be a bit more specific than that. But it's usually checked out by people in the Rust community. So if you wanna get somebody who's a Rust expert or wanna be Rust expert, that's a great place to go. The second one is Rust-focused events, such as this one, and conferences, such as Rust Nation, Eurorust, RustNL, Rust in Zurich. In Europe, you have to take your pick. Like, out of curiosity, raise events. Who here works with Rust on their daily job? A lot more than I was expecting. Who here wants to work with Rust at their daily job? Still a lot. So this still works. You can go here and say, I'm hiring, and get a bunch of people. Said that, that might not be enough, depending on what you do. So there are recruiting agencies that start to specialize into sourcing Rust developers. I don't have any specific names to give out, but if this is a kind of service that you need, there are folks out there providing it, so just make a little research. Said that, multiple companies of all sizes are adopting Rust successfully. You've seen the slide from Ernest at the very beginning. There's too many logos, like we need to get a deck. And I've seen, I keep seeing this happening at various scales. Like working at Mainmatter, we get the opportunity to speak to a lot of folks. And there's a lot more Rust that you might think, in a lot of places you might not think of. Said that, take everything I said in this talk as kind of a playbook. Like, it's a bunch of different tools and techniques that you can deploy situationally. Depending on the company, depending on the stage, depending on the project, you might want to go down one route rather than the other route. You take it as a reference that you can pick and choose from. Said that, if you need help, obviously, come and reach out to us. This is the digital place where you can find us. Otherwise, I'm here, flesh and blood, and you can grab me pretty much until the end of the event. And that was everything. Thank you very much. And since I'm both the speaker and the presenter, since it's 55, I think I can take 2 questions from the audience, if there are any. Can I get a mic to the man? Thank you, Zach. Do the honors.
So I was wondering if you had any recommendations for companies that do training. Obviously, Mainmatter is
Yes.
up there. I've heard, I'm aware of Ferris.
Yes.
Are there any others that you consider to have good reputation in the Rust community?
I mean, there's, depends first and foremost what kind of training you want, right? And I usually bucket that into 2 categories. There's teach me Rust training, and there's specialized trainings for some specifics, subdomains. Getting started with Rust, there's a variety of companies offering it. Mainmatter is one, Ferrous System is another one. There's Tweed Golf in the Netherlands. There's Red Badger here in London, and probably many more that I'm not aware of. When it comes to specialized training, then each of these companies has areas of expertise. So Ferrous, for example, is specialized in embedding. That's something they do very well. That's something we don't do. Like if you come to me and say, I want an embedded training, I'll tell you, I can't offer it. Go ask those folks. While if you come to us, we do backend, we do advanced, basically Rust in the cloud type of things. So depending on what you want, I would say research what the company specializes into and make sure that it's aligned with the type of learning path that you need to support your engineers, if that makes sense.
Thank you.
And another one on that as well is conferences are a good way to test, right? Like if you are evaluating, for example, Mainmatter as a trainer, rather than booking a private 20 people private training from the get-go, you can go Rust Nation, you grab 1 ticket, you go through the workshop, you're like, are these guys good trainers, yes or no? And that's a way to trial, if that makes sense.
Makes sense.
Cool. Well, that was all questions for now. we're going to take a 10-15 minutes break, more or less. There's a bunch of drinks in the back, and then we're going to start again with the panel at 8:10. Give it a take. to get started, Alex? Yes? Cool. So, this is a panel about Rust in production, mostly just as an opportunity for you to ask a bunch of questions to people using Rust in different ways for different reasons. And I'm going to kickstart the panel with a few questions, but at any point in time, if you are in the audience and you want to ask a question, raise your hands. I'll see you, and then we'll get the mic to you. Now, some of us you already seen. I've introduced myself. Edward has introduced himself. So I'll now pass the mic again to Nodar to introduce himself, and then we go around.
Yeah, sounds good. Well, I'll do one once more for maybe people who joined later. My name is Nodar. I'm co-founder, CEO at Shuttle. Originally from Georgia. I came here to the UK when I was 16 to live by myself, to study. Actually on Friday becoming British as well, so big, yeah, a long time coming. Yeah, so my story is just before starting Shuttle, I was working in a quant hedge fund, and we were trading behavioral strategies, and we were obviously using a lot of Java and Python there. It was fun, and you know, in 2019 decided to start a company, and 2020 got into Y Combinator. That sort of changed our trajectory quite strongly, and Shuttle probably beginning of 2022. That's when we started working on Shuttle. Our users brought us to the idea of working on backend development. And yeah, since then I've been quite enjoying building the product and the team. It's been quite a fun ride. I'm here to probably provide more, like we have very talented people here to provide more technical perspective. I want to bring in my point of view, which is more the business founder side and what it is to deal with Rust, you know, when you're building a startup. So that's me.
Thanks, Nodar. Hi, everyone. I'm David. I originally started out in physics and then worked my way into scientific software, working at various places like the Diamond Light Source and the Wellcome Trust. And then I moved to the West Country, where I still live, and worked with various large government organizations. I sort of moved from building to designing apps. So, you know, we worked in a big organization. They had a big engineering department, and that wasn't really producing the sort of work that the people who worked there needed, right? The business needed. So we had this innovation team that was there to really sort of sit amongst all the analysts and all the business and do work for free and build stuff that they needed. And we had a few great products, and I really enjoyed that sort of finding that fit and really understanding what it is that customers need. And I've always sort of enjoyed that sort of dynamic, sort of startup-y life. And it was kind of like an entrepreneur. Sorry, I'm not used to using a microphone. It's kind of like being an entrepreneur inside a company. And then I've known Matthew, my CEO, who's sitting over there. Hi, Matthew. I've known him for years. Our wives are best friends from university, and he came and suggested we form a startup. He's got a background in sales and cloud services and growing businesses and scaling businesses. And you know, I thought that would work really well with where I come from, which is sort of innovation and creating products and trying to find product market fit, and I could kind of build things as well. So we founded Arwen AI, and 3 years ago, and it's been a really exciting journey with lots of ups and downs. And you know, I'm the CTO, and we've started thinking about Rust, which I think we'll go into in a little later. But yeah, it's been a great journey. Startups are pretty wild fun. Oh yeah, so Arwen, yeah, thank you, Nodar. Arwen invited us here. Nodar invited us here. Sorry? What do we do? Sorry, that's the marketing talking. Arwen AI protects sort of social media accounts from unwanted content, protects audience, brands, and the staff that work with social media content. We social media sort of services. So we work with big companies like Mercedes Formula One, ITV. We protect all the channels for all their shows. Stuff comes in. We collect a lot of content from Facebook, TikTok, Instagram, all of those services. We classify it using machine learning. Some we buy in, some we build in-house. And then we moderate based on what that customer likes and doesn't like, right? So football teams don't mind a bit of swearing. They're kind of well known for it. But daytime TV is a no-no. So, that sort of content gets removed from their channels very quickly. It improves, we think it improves engagement and conversation. It reduces hate speech on those channels. So yeah, that's what Arwen does, and we've got a bit of investment, and we're on the road to profitability. We've got a good sales team, and we're getting some traction. So it's been really exciting.
Nice.
Thanks.
So let's get a little bit to know you better, right? This was about who you are. I like to start these panels, since this is a Rust meetup in the end. What was your journey into Rust? And I think let's start from Arwen, because obviously you are using Rust in the product, which is a slightly different perspective from Shuttle, who's, I wouldn't say selling Rust, that probably is the wrong angle, but it's a platform that tries to sell to Rust developers. So you're looking at it from a slightly different perspective. So let's start from David, perhaps.
Right. So the way we wanted to build a startup, and I think a good way of building a startup is to build extremely rapidly, cutting a lot of corners to find product market fit, right? There's no point in building a cathedral and then no one's religious, right? That's like, I mean, that's a bad analogy, but you've got to find a fit first. So we built extremely rapidly with tools we needed, we knew, and now we've come to a point where we sort of recognize what we do need to really have, a very stable architecture. We need to redesign some things, we need to do some rewriting, and we need to consider an alternative to the TypeScript code base that we have. We have had quite a few problems with that. So, what drew us to Rust? How did we start this personally? My brother, who was supposed to be sitting where I am, but he's unwell, unfortunately, at home in bed. He wrote a little tool called LK, and it's just basically like a command palette for all the bash scripts in your project, and we have a lot of bash scripts, a lot of configuration. It's part of some of the technical debt that we've got. And LK is sort of like, it's called LK because if you flap your hand on the keyboard, you kind of hit LK, right? So it's supposed to be very rapid execution of your project's commands. So we built that, and it was fantastic, and it worked really well. We use it every day. Look it up on GitHub. And then we wrote some other command line utilities in it, and I did rustlings, and the rest of the team did rustlings, and we talked about it, and we did merge requests on James's code, and we started writing some real production services in it, and had a great experience. So.
Cool. I mean, my story probably started back in that hedge fund. The first person to introduce me to Rust and my other co-founders as well was Damien, our CTO at the time. So his main argument for Rust was a bunch of much smarter people came together and engineered a compiler that's going to prevent me from making stupid mistakes. And he was quite excited about the overall developer experience and was kind of raving a lot about it. And as I mentioned, we were, in that hedge fund, there was a lot of Java and Python. Things would often break in production, and so caused a lot of uproar. And when you need to trade and your model is not giving you signals for some reason, or your trading platform is Borg, it's pretty stressful and stressful times, I would say. And so that idea of or that promise of better developer experience and ultimately more reliable software was pretty appealing at that time. Now, of course, when you're starting a company as well, and I don't know if we want to touch on that later more, but when you're starting a company, it's much more pragmatic than normally, right? Than this, and we needed to build, let's say, reliable software, and so it made sense to choose Rust. But I think in our case there was a little bit of whoever's leading the technical, whoever's the most technical person, it ends up choosing the stack. and there's a bit of that. There's obviously people can challenge sometimes, but at that time it was quite a light discussion. We didn't even have a discussion. It was like, okay, we're doing this in Rust, and it ended up taking us down beautiful path that now looking back, I can connect a lot of dots and see like why it was an amazing decision. And actually, us sitting here right now is because of of that. But it was kind of like almost a non-decision at the time.
I mean, it happens very often, right? Like you go to a startup and you ask, why are you using technology, right? It can be Scala, it can be Haskell, and the answer is, well, the first engineer was a good Haskell engineer. And it kind of like snowballs from there, and snowballs probably is the negative view, but it can bloom or sink.
In our case, it was James's enthusiasm that was infectious, and we all started sort of getting interested in it, so yeah.
Gotcha. So you mentioned before another, I think that's interesting, that obviously building with Rust has a perceived feeling in most cases that you're getting something that is more stable. Or to say it differently, that you're doing more work up front, making sure that it's right, instead of doing work after the fact, debugging it so that it becomes right. But there's also trade-offs compared to other ecosystems. Like if you take Rust and you compare it to Python or you compare it to JavaScript, you're comparing ecosystems of different orders of magnitude in terms of developers available, libraries available, age of the tooling, which has positive and negative connotations. So how do you balance the speed that you get from a larger ecosystem, where very often you can go on NPM, this module, this module, this module, this module, little bit of glue. I mean, might not be beautiful, but it works. And instead, the Rust ecosystem, where it's a little bit smaller, perhaps, and sometimes you might have to write stuff yourself. For example, how often does that happen? And we can start probably from Edward.
Okay, I would say, looking at the way Vortexa is doing things, because of course it's a startup and we kind of grew from nothing, and just the point that you just made, that we started using Python because we hired a data scientist, and data scientists do Python. We started doing Java because I had a background in investment banking. They hired me, and that's the hammer I was holding. So a lot of this was just sort of ancient history, how it came to happen. But now we're more established, we've got a code base, and we're trying to refine things. We're still trying to move fast. It's a scale up. There's still lots of work to do. It depends on the problem domain, and I think we have several. We have a data science problem domain where still Python is king. We need to keep the data science developers working rapidly. And it's not, these are not software engineers, and it's not realistic that they're going to be doing Rust, to be honest. There's another domain as well where we have reasonably low latency, and I would say we haven't cracked the solution of streaming data using Rust. There are stream frameworks out there, but they're not comparable today with the stream frameworks that we're finding, for example, with like Kafka streams on the JVM platform. So there are some constraints where Rust doesn't today feel like the right tool. There are other things where you saw in my presentation where we can make surgical changes and make a massive difference. So we do run into issues where I would say that you feel that the ecosystem is small, where, the classic one is like reading a Parquet file. You do that in Python in one line of code. There are libraries to do this in Rust, but it's not as mature. So it is something we're running into, but it keeps improving.
I guess from my side, there's definitely a big change that we've seen, like starting in 2019 to now. The scale of the problem has changed. And that's probably one of the things that's giving a lot of hope, right? So things are improving in terms of the ecosystem like maturity, readiness, if you want. We still do run into problems. I mean, the one that we have right now is there is some feature of Datadog that we would like to use, and we're using also tracing framework, and they don't play nicely, and there's a certain feature that we were not able to use because of this, which is probably a problem that's solved, well in other ecosystems or has been looked at already, but it's just something that we need to, let's say, invest more time into and try and find workaround, so to speak. I would say that this is more like feeling. I don't have hard data to say, but feeling based, it's getting better. And
but you touched on an important point, right? Because when you look at an ecosystem, there's the size of the ecosystem, as in the ecosystem built by people working with the language, and then there's also the investments that companies are putting into certain ecosystems. And like Datadog probably has an extremely polished Java SDK. I haven't used it, but I'm willing to bet a lot of money on that because they see that as a big market. Then if you look at Rust, you get AWS as a nice Rust SDK. Does GCP have a nice Rust SDK? No, they don't. It's not even first party. So that is an issue which I think comes up quite often when talking to people. Like, you are not going to find ready-made, company-maintained, like SDKs for services. Like, very often you find volunteer-maintained, variable quality, good or bad. Anyway, David, sorry, I cut you off.
Yeah, that's exactly our experience. You know, we integrate with a dozen or so external systems. So one of the great things about Rust is how its correctness and its modeling makes it very easy to be very precise about integrations. When you have lots of integrations like that, I'm sure you know, it can cause a lot of bugs in production when people, you know, tracking down how APIs change and that sort of thing. So most of those external systems do not have Rust libraries, but a lot of them have Twitter libraries or, you know, JavaScript libraries or TypeScript libraries or Python libraries. So we're having to do quite a lot of work there, really. It is very nice to have now in production AWS SDK. that's very useful, and we make use of that a lot. So yeah, it's you know, in some ways, writing all this stuff yourself, we only need to use a few key parts of these APIs, and having a deep understanding of exactly how they work and defining that ourselves and having that control over those is not necessarily a bad thing. You know, we're not trying to get up and running really quickly anymore. We're trying to build a very stable system. So building it ourselves and understanding it deeply is, yeah, it's fine. It's reasonable.
It'd be nice to have the option, I guess, right?
It would be good to have the option. But, you know, I had that option with Twitter. I used a library, it was V1, and I wanted to use V2, and they didn't support it, and they didn't update it, so I had to get another library in and do another library assessment. So, you know, even if there are libraries there, they're not necessarily good libraries.
Yeah, I mean, that's the other thing about third-party code. Like, you need to check it.
Exactly, yeah.
Takes time on its own. I think this is a nice segue into, I guess, the following question, which is still a little bit negative looking, but I think it's important. You know, I was speaking before with a few people in the audience, and there's a lot of like Rust flag waving when you go to Rust events, right? You know, Rust is amazing, does all these right things, which I think is good. At the same time, though, you want to give a balanced view. Like, you want people to see the good and the bad, because in that way they can make somewhat reasoned, you know, informed decisions. So the question I have is, what do you think is the top challenge you have with Rust and Rust in general? Like, what do you see as the main problem or the main thing that needs to be solved or improved going forward?
I mean, it's probably recruitment. You know, there's a lot of people who probably want to work in Rust. There's a hell of a lot of TypeScript engineers out there, and they're pretty cheap. I mean, to be absolutely honest with you, it's hard. There are fewer Rust engineers, and they're very expensive. You know, personally, as an engineer as well as a CTO, you know, compile times are a pain. I've got a MacBook Pro, just pre-M1, and it's pretty slow. You know, it's like that dev cycle that you mentioned a number of times is just a bit too frustrating. That's a minor thing, but I'm sure we've all come across that.
Yes.
Yeah. From my side, a few points probably. I mean, again, this is like a startup perspective, so take with a grain of salt. But iteration speed is probably not like the strongest suit of Rust. You build code that's you know, probably going to be better quality in most cases, or at least you know, you will need to do a bit of work to appease the compiler. But you know, once it's done, what it sort of leads you to as well, and that's kind of the other side of the coin, is that you end up with generally better code that's more maintainable. And so, you know, when you're prototyping and doing those iterations, happens quite often. You're trying to move fast and break things, right? And you have some sloppy code, and that happens. I mean, that happens in Rust as well, as you rightly pointed out, Luca. But the magnitude is different probably with Rust. The other thing that we've noticed on the hiring front is I think it's probably like to the point about Rust engineers being in high demand. At some point there was a lot of crypto startups looking for Rust engineers, and that was also like driving the salaries up quite a lot. Nothing against crypto startups, but you know that made it even more.
Saying nothing against high salaries, but yes,
well, also nothing against that too. And then on the other hand, hiring, and maybe worth touching more deeply onto hiring. But what I find is that generally you, for some reason, the quality of let's say applications tends to be higher. So what we see is that whilst there's less people maybe than in other ecosystems, generally people are already quite well versed, and that's pretty good. Even if they don't have a lot of production Rust experience, seem to be high quality candidates who you have more confidence in sort of like coaching and bringing them up to speed. That's what we've seen. Like it sort of, there's a little bit of a filtering already done for you, but it does mean that you're selecting from a smaller pool of candidates, and
this
that's
is called the Python effect, from an old article from like Paul Graham. I think we're talking early 2000s, where he was basically describing exactly the same effect for hiring Python engineers back in the day when Python wasn't that hip. Because if you are following the recent trends in technology, that already puts you into a smaller pool of engineering talent, and that means that people coming out of the pool generally are more prepared. So it's not necessarily about the technology, it's about what that signifies in the interest of that person.
I would agree with that. We interviewed 2 Rust engineers last year, contractors, and I would have hired both of them. And the one we did get to join us, who's in Kyiv, he's very good and he's doing really well. The stand-up this morning, he said there was a missile attack last night in Kyiv. So that was a very sober stand-up, and I have to say Jira didn't seem quite so important after that. But it's we've spoke to 2 people, interviewed 2 people, both good candidates.
I think it's interesting the comment you made about moving fast and breaking stuff, because of course that's what you do when you're a startup and you're beginning. We're now a scale-up and we're still moving fast and we're still breaking stuff. Probably too much stuff. And I actually am beginning to think that I do agree with the point that, in a sense, because how stringent working with Rust is, not the compile times, because I do have an M1, but working with Rust can slow things down on the initial delivery. I actually think it's really worth the dividends of not having to go back and do as much maintenance. So I actually think one of the problems for me I see with Rust is actually the perception, because in our business we're continually working on 101 different tasks, different things, different projects, fix this, build that, new feature, etc., etc. And the question is, is Rust a suitable technology for this? And I like to flip it on the head and think, why isn't it? Now, sometimes the answer is it isn't. If we were talking about the ecosystem earlier, and it could be that the particular problem being solved, there isn't a sufficient library support. Streaming will be a good example of that. But quite often, I think, because of these, you pay up front and then you get the dividends downstream, we need to start thinking a little bit longer term. And I think, getting that maintenance benefit in there really does pay dividends.
Can I say something about refactoring? We have a product market fit, but we're still developing and changing things. We're still breaking stuff, and Rust is very good to refactor. It's very reliable to make changes. There are some areas of our TypeScript code base which we don't want to touch. We don't want to change, but the same is not true of any part of our Rust. We happily refactor it all. So I think that's a big, that's a big benefit.
Yeah, that is true. And I wanted to get back to something Edward said. there's a reputation problem, which is very akin to momentum, if that makes sense. Like when something feels like having momentum, it just kind of becomes a self-fulfilling prophecy, right? Like, oh, I don't know, this framework is getting popular, and then everybody convinces themselves that it's getting popular, and then it gets popular. And this is, in a negative way, something that happens with Rust when it comes to the perceived difficulty or the perceived learning curve. Like if everybody starts saying, you know, Rust is difficult, but then kind of becomes that becomes a truth, that becomes a factoid, like Rust is difficult, and then becomes the way you drive the conversation. The reality is that the fact that Rust is difficult is, to an extent, an historical fact. Like it's what you would have, like if you tried to learn Rust 7 years ago, before the non-lexical lifetimes were introduced, then you would truly understand what it means to find the border checker. It's like on a completely different level of annoyance, like user unfriendliness and just terrible error messages. Like there's a gulf between what Rust was 7 years ago and it is today. But that reputation, like, you know, that refrain that it is a difficult language with a steep learning curve stays. Even if there is data, like from, for example, Google, who runs a fairly large internal training program, where they say, you know what, you know, we train a few hundreds, thousands people every year, and we are looking at Rust, and people become productive in a month and something, which is perfectly in line with what we know from Java and Go. But still, like, that is not enough to kind of move the public perception a little bit, because that perception has momentum and it's very difficult to stop it, if that makes sense.
Can I just add on that, that I think some of this perception is actually at the developer level,
Yes.
where they have this hammer, they have this tool they're holding already, which they're very familiar with, and it's the easy path to just continue with what they have. And choosing an alternative technology, trying Rust, is definitely going to be more difficult the first time to do it,
Yes.
and the second time to do it. But like you say, in weeks, a couple of months, they can definitely pick some up and be very productive, I think.
Yeah, it's the difference between saying, which is perfectly reasonable, like we are very experienced with this piece of technology, it's gonna take us less to do it with what we know, which is the truth. Like there's no denying that, than to say, this new technology is too difficult. Then you're moving the problem from a fact to a perception, which is a slightly different thing. Anyway, wanted to give a chance to the audience to ask questions if there are any. See one end right there.
I didn't really have a question specifically about what you were talking about. It's more a bit of something about advice. So I'm going to be building a new internal tool, and I need to pick a front end, back end sort of thing. I was wondering, did you build any of your front ends in like a Rust front end thing, like Leptos or I can't pronounce it. It starts with the D and it's Deoxys or something. Thank you. Have you used any of these ones? And what's your opinion? Like, which one would you say is more mature and therefore worth picking over the other one? Or since it's a relatively small project, it might be fine to use the more newer / experimental one, if you see what I mean. So I was just wanting a bit of advice.
Who wants to take this?
So I've done a lot of React. And that's...
You said that as if it was a bad thing.
Well,
like,
you know...
Let me get it out. I've done a lot of React.
For the record, React makes a lot more sense than Angular.
I have also done Angular. I wholeheartedly agree. You know, I've got an investment in it. So although I consider these things, they all seem quite early stage. You know, I know how to deal with a lot of problems with React. And, you know, there's a lot of different ways you can build front ends and lots of different considerations for different types of applications. And I didn't have the confidence that any of these things would be able to help me with all of them. I'm much more interested in using Rust for APIs. We have a GraphQL, a Rust API, and a TypeScript API, and we federated them, and we're slowly switching over from one to the other, which has been quite a good migration path from a TypeScript backend to a Rust backend. And it's just way more stable. It runs on a fraction of the resources. It's been a good decision for us. But no, I don't have any experience with those languages, I'm afraid.
I guess a more general way to answer that question is, if you go for something that is more experimental, there's a much higher chance that you'll have to peek under the hood. And so, how comfortable are you to do that, and do you have the time to do that? If the answer to those questions is yes, then you know you can go pick. If you're like, I'm primarily a backend developer and need some front end just to get some stuff done, you're probably much better served picking something that has a gazillion learning resources out there, because you just don't ramp a lot faster.
maybe just to add to that, like from Shuttle's perspective, right? We sometimes people refer to us as Vercel for the backend, and it's an interesting point. Like we ourselves don't use Rust in the front end that much. It's so our website, for example, is on and the console is on running on Vercel, so Next.js. So nothing against JavaScript in the front end, and I think it's we were actually discussing this earlier with Luca. It's interesting because the fact that JavaScript has been a standard and has created this amazing ecosystem around itself. Because it's the language of the browser, has led to the creation of such amazing developer experience as Vercel provides for the front end. I'm not, I'm not an investor or have an interest in that, but it's generally a great product. And so what we are trying to do is create that kind of smooth developer experience in the backend, right? And so, for example, a lot of our templates that we've created, we create this like starter examples, or just like build your API in Rust and then make it play really nicely with your Next.js front end, right? And people love that kind of stuff because it lets them, on the one hand, use stuff that they're used to in the front end that has amazing libraries, has great tools that are already out there, and then in the back end use the latest and the greatest, which is Rust.
Thank you.
Behind you.
Please don't throw it that close. Question about, I guess, momentum and the library ecosystem that you spoke about. Possibly a question for Ed. How old is Pathfinder? Do any of you guys have a product or a piece of Rust code that's been around for a long time in production? What's your experience been with whatever library or framework you decided to pick, back in the yonder? And how is that compared to other languages that you've used? Because one thing I've found, having used Rust since slightly before 1.0 and for production code since like 1.10 or so, is a lot of the stuff that we built back then now still can pass perfectly, still works, but the CVEs begin to stack up, and people ask, when are you going to fix that? And you go, oh, I'm just going to bump the dependencies and nothing works anymore. And has that been your experience as well? And are we getting out of the woods with that as stuff gets more traction?
It's a good question. Vortex is about 8 years old. Pathfinder is at least 6 years old, I would say. I can't remember the precise version. It might be like 108 or something like that when it started. It's the same era. One thing we've very recently changed, actually, in this year, we were using Risotto to access Amazon Web Services, and we've now swapped that out for the official SDK. I have noticed in the past, I think there's one period around version 120 or something like that where there's quite a big wave of breaking change and we had to do quite a bit of work, just once. In general, it's not been too bad. I have got one Rust project which is stuck on 1.7.2 because it won't work on anything newer, and I need to address that. It's not a burning issue, but it is an issue. It does happen.
I'm thinking more about, I think the compiler has been very stable, and certainly in the few cases where it has broken stuff, it's been well advertised that it's going to break stuff. I'm thinking more about, I didn't necessarily want to pick packages apart because, we're obviously very grateful to people, but Actix 2, Actix 3, Actix 4, like, if you want security updates, you had to go up, and going up was not simple.
I mean, there's Rob back there. You can complain to him.
Throw objects.
I'm not going to point, but...
I mean, for me, the actual example was like Actix 2 to Actix 3, I think. I can't remember exactly the version, but it was a case of where we basically had to decide either we're never going to touch this again, which we didn't want to do, or we have to do a wholesale upgrade. And that was annoying. And, whether we could get... If you look at something like picking a very common example, Spring Boot, which is very widespread, they do like patch updates and security updates for stable library versions for ages. And are we getting to the point of maturity in the library ecosystem that we could start to not expect but hope for that?
I think there's 2 things to, there's 3 things to consider here. Number one is that Java has more affordances to patch stuff without breaking, which Rust doesn't have. And I say this, and I've seen evil things done to patch things without making breaking changes. There's a lot of evil debuts, but very useful stuff you can do with the JVM. Rust being compiled puts you in a much stricter jacket. You can't do as many things. There's also, and I think that touches upon the point you were making at the beginning, yes, the code still compiles, but it's no longer idiomatic. And I think that goes also on the Actix kind of example, right? What happened between Actix 2 and 3, or between Actix 3 and 4? You got async await stabilizing. And so suddenly what used to be, oh, this is the state of the art of writing a network service in Rust, it's like, this is the clunky old way of doing things. Now we got this much better shiny armor. I mean, yes, I could keep the framework and then version forever and let it become obsolete, or I could write a new version and then that's gonna be good. Or you got Tokyo stabilizing to 1.0. It's a breaking change, that's a big wave. Am I gonna be stuck on a version that has no support? Obviously I need to bring forward. Now, some of these things are ecosystem changes, like Tokyo. Some are language changes, right? Like async await, yes, it was a known-breaking change, but suddenly it shifted what was the state of the art of doing things. And this still keeps happening, right? What was it? Rust 175, which came up right before New Year's Eve, shipped async functioning traits. Now, I can guarantee you, I'll make this other prediction, that you'll see another wave of breaking changes, because a bunch of libraries that before had interfaces that were working around the fact that they didn't have async functioning traits will do a new version with async functioning traits. And that will cascade through your dependency tree and you'll need to do a big upgrade. So it is true the compiler has been stable, but in reality, that incremental addition still creates cracks into the ecosystem because you can do things in a better way and people want to do things in a better way. Now, if the size of the ecosystem grows and there's a lot of commercial usage, then you'll get enough people and funding to do what you're suggesting, right? So yeah, I'm going to release Actix 5, but actually have enough backing to say that Actix 4 is going to be maintained for 3 years. Rob is making signs, I don't know how to interpret those. I think he's saying yes. But it's like you need things to settle to be able to offer that support, and you also need a commercial ecosystem that makes it so that it's viable to provide that support. If you got a random guy in London maintaining a massive ecosystem alone, how much can you do until he breaks? So that's just a different perspective on that.
I could add that Pathfinder is based on Actix, so thank you, Rob.
A lot of endorsement.
Absolutely. We did go through that wave of breaking change, exactly as you talked about, for those reasons. It also uses Tokyo, so we went through that breaking wave of change as well. It's all happened in Pathfinder.
Do they end out patches? You know, I was there. You kind of
should do. I should get the stickers on the laptop. Yeah, I used Actix 1. Yeah. But it's not been terribly painful. I think the next wave of pain is I know I'm using very out-of-date Parquet libraries, and they're very breaking changes. So that's going to be quite interesting upgrading that. But I would say this does happen more in the Rust ecosystem than other ecosystems, because the one that I'm used to before is Java, and they tend to do about 18 releases before they consider removing something completely. Their deprecation cycle lasts decades, which has its own set of disadvantages as well.
Yes.
But yeah.
I guess another thing, just to remark on that again, is that this applies beyond Rust, right? Like if you're running any piece of software, the farther away you are from latest, the more problems you're going to have when you eventually will have to catch up with latest. Like even the technologies that have very long support cycle, they don't have forever support cycles. You know, if you've been stuck on the JVM version 8, eventually you'll have to come on version 11, and and then version 17.
Gosh, who would be stuck on JVM version 8?
Not saying anything. There's no shame. Like you can come out and say I was on JVM version 8, but there's no delaying forever. Like there's some software maintenance that you gotta bake in. Obviously, the more immature the ecosystem, the more maintenance you're doing because things churn a lot faster. But it's part of like the KTLO, like keeping the lights on of a service, a code base. And obviously, the more code you add, painful it gets. No, it was me, don't worry. Anyway, any other questions from the audience? See, well, let's get that down there, and then we'll go back to him.
Which one?
Don't throw it as a beer. That's gonna get very ugly.
Beer, I'll walk.
Do it like from the bottom to the top.
I don't want the bill.
I already saw that light completely destroyed. Yeah.
Kind of on a similar point, do you think that nightly is maybe a bit too popular? I see a lot of libraries where it's like, oh, to use this, you need nightly version, this and that. Or I think I'm seeing it less these days, but I still see quite a lot of libraries that are like, oh, yeah, you should really use nightly to have a fun time with this. Personal experience recently migrating a old web service of ours that was, I managed to get it up to nightly at some point in May 2022 before we couldn't upgrade it any further because a certain dependency needed a specific feature but was removed the next day. So yeah, do you think the popularity of nightly is a good thing or a bad thing for the Rust ecosystem?
Let me get David's opinion on that.
I stick to production-ready versions of everything, I'm afraid, apart from AWS SDK, which I used for a little time before version 1. So, I mean, I don't really have a view on that, I'm afraid.
Although I think
James probably would.
It has been production-ready for long before, it just wasn't stable.
That's what I assumed.
I can tell you that from being on that team. But on nightly, so that's actually it's very interesting because I think, what was it, a couple of months ago, the team maintaining Crates.io is starting to collect version information. So up until now, you know, what version are Rust users using was a very fuzzy question. And there was really no hard data. And that comes a lot in conversations around what minimum Rust version should I support? Like, is it fine to require Rust 174 or should I stick to 163? Should I stick to 140? And it turns out that actually most people are unstable. Like the cowboy days where most of the libraries require nightly seems to be kind of behind us, with the caveat that there are ecosystems that are still bound to use nightly because there are some key features that are not unstable. Linux kernel, one of those examples. Some embedded stuff still requires a lot of stuff that's on nightly. But if you're talking specifically about, you know, backend API development, CLI development, you don't need. You might want to have some fun with nightly, but then, you know, that's a personal choice with consequences. It's not needed.
I think I would second that. I have had fun with nightly. You can quote me on that. But actually using it in production code, no. I was actually more scared than my fellow panelists. I've only started using the AWS SDK when it became stable. We want stable things in production. I think an important thing for me is repeatable builds. I do want to be able to rerun the same code through continuous integration twice and get the same results out, and I get upset when I don't. So I need a stable backing there.
Let's move here.
So my question is about cargo and its integration with other build systems. So cargo as a single build system for just Rust projects, great. You've got workspaces, you've got all kinds of nice things you can do. You've got it's perfect. If you are trying to integrate it with other build systems, so you're building a native library that then downstream dependencies want to use, that I have found to not be such a well-supported flow. And I've started looking into, so we've just, for a very long time, about 7 years now, just been using a script where we say, build the Rust project, now build the C++ project, or C or whatever. And I'm just now looking into alternative build systems like Bazel or Buck to potentially replace cargo. And I'm curious for, if you've looked at kind of polyglot environments where you want to build things with downstream native dependencies, how do you do that? Is it just a series of build this, then this, and this? Or is it something more involved, like one of these advanced build systems?
I think Edward is the best person to answer that.
I'd say, so there's two cases that I certainly got experience with. One is with integrating with Python, one is both integrating with Java. In both cases, it's these other languages that are calling out to Rust. Rust is a library. It's not Rust code invoking those languages, which you can do. I don't know why you would, but you can. I would say it's a step-by-step build for us. So in the Python case, we're using Maturin, which is quite funky and I would say maybe a bit delicate. But this orchestrates the correct incantation of invoking cargo with the correct parameters, which gets the build just right, so it can then be exported as a pip artifact and installed into the Python ecosystem properly. And we're having to do this on multi-platforms as well. Most of our developers are using Macs. There's a mix of Intel and Apple Silicon. Yet in production, we're in the cloud, and we tend to be using x86 as well. So we've got a few build targets as well, which complicates matters as well. We have individual builds for those. We are using cross-compilation. For the Java thing, that's actually simpler in a way because we have a standard cargo build which produces a binary, and then that gets wrapped up into a jar using Maven. So we're just using the standard tools for the ecosystem that we're using. So I would say, yes, we are sticking with cargo, but I feel your pain.
Okay, thank you.
I think to elaborate on that, I think it depends on the level of sophistication that you're after. In the sense that if you want granular caching or a build system that understands the Rust compilation to the point that you can cache things fine-grained, then yes, like you need to look into something like Bug2 or Bazel. If you're happy to use cargo as a black box, you know, as in I have this process that's going to give me the Rust binary, and then I can kind of encapsulate that into a make file or something simpler, in quotes, then obviously integration is simpler. But the problem is that cargo does a lot under the hood. A lot of what it does is not exposed. The famous, build plan feature is planned to be removed. Metadata tells you some stuff, but not all the stuff, and sometimes not the true stuff. And so it's very difficult to kind of peek into the black box, and you kind of feels like you're re-implementing cargo in the other build system, which obviously is complicated and time-consuming.
Yeah, it definitely feels sub-ideal across the board, which is why I was wanting to ask.
One thing I want to add there actually is as well, in our build system, ultimately we're creating Docker containers as well. And we do use Docker layer caching to speed up our builds. Quite often we use the trick where we will have like a dummy library file in Rust, which is literally empty. And we just get the Rust compiler to build all the dependencies. Because they're usually, especially if we're pinning our dependencies, they're pretty static. So that can be cached. And then the Rust build is actually really fast because it's just building our code and the bit of our code that's changed. So there are tricks like that to speed things up.
So I can see from the back that the pizza has arrived, and now the smell for the audience, and keep this panel going is going to be very complicated. So I think we can wrap it up with one last question, if any. Oh, I see one down there. He was a faster end. I don't know. Fight it out. Yeah, down there. Yeah.
So you mentioned data science and artificial intelligence among the organization. Do you have success deploying or even like training models on native Rust stuff like Candle or Lympha maybe, or at least maybe deploying Rust without Python as a dependency, which is a pain for dependency managing production?
No, we have our machine learning models hosted in a Python container sitting behind an API, and that's how we integrate with them internally. So no, we've not done any integration like that.
I think it's the same story over here. We're still on the data science side. It's very Python world.
So I'll break the consensus. Well, I studied Lympha, so I have a biased opinion on that. And we, as Mainmatter, have also assisted a client in building a very large like pre-processing pipeline in Rust. We're talking trillions of tokens of text to be crunched. And the reality is you can do it. Like it's totally doable, but you're going off the beaten path, which, going back to what we were saying before, it means you're going to have less libraries. It means you're going to potentially have to train people. So it only makes sense to do it if you have a reason to do it. Like one possible reason, as it was the case for this client project that we did with Aleph Alpha, is you have a lot of data. A lot of data means a lot of compute. A lot of compute means a lot of money. Then if you can, shrink the size of the compute fleet by a factor of 10 because you're using something that's more performant, then it makes economical and business sense to train on Rust. If you want to train on Rust just because you have a little model and it's going to be done probably just as quickly in Python, then you probably want to use Python. But I guess the short answer is it's possible, it's viable, it's not as streamlined as it is in Python. You probably need a good reason to do it. I wish it was simpler, but it still isn't. And with that somber note, I think we can wrap up the panel. Please give a show of hands for all the panelists. And enjoy the food in the back. We can stay in the space for 30, 40 minutes, so